Namaskar, welcome back. So, we were discussing in the last lecture about the significance of the historical documents, historical seismicity, and the modern seismicity. And we also discussed in brief that what is the significance of identifying these weak zones, that what we call active faults on surface, and uh, practically it should nobody should be allowed to construct any structure, civil structure, and most importantly the lifeline structure across this type of weak zones which are capable of producing earthquakes in near future. But as we discussed that in past, like during the historical time, without having the proper awareness, people have constructed the structures on fault, and of course what were the effect of fault. So we had some sort of a discussion also that the European side what they have catalogued, looking at the damage which has been observed by the structures, and some categories were been built, and the evidence what one should look at, those things were been discussed. Okay, and we stopped somewhere here discussing about the fault which is in which crosses the Pinjore Garden, and the Pinjore Garden, Pinjore area, and the Pinjore Garden is basically constructed on top of across this fault. Okay, and the area which, if you carefully remember, I was showing one map which clearly talks about. So this is the map here where this red line has been by showing the fault trace, okay, on surface, and the area is what we call is Pinjore Dune, like similar like Dehradun, Son Dune. So Dune is an intermountain valley, the valley between two mountains. So that is the geomorphic setting of this area, and fault has crossed this, and multiple earthquakes have been triggered in the past also on this. Okay. Now coming to the part further, if you move in this topic, then we have the evidence from Kutch region, and then from Aichatra, as I mentioned in my previous lecture. Okay, so this again for this is again Pinjore Garden fault only, and the structure which has been constructed on top of it is your the big step, what we call, and this was the construction was been done in 17th century, the way back. So since then, because there is no damage or any signature of damage has been seen in this garden structure. Okay, so there is no earthquake since 17th century on this fault. So you can see this the height here. This one is almost like more than 12 meters or so. On top of that, the structure has been constructed, and as I mentioned that this is a typical Mughal garden. So the advantage of this gradient was been taken to allow the water to flow through the center pathway. Okay, then there is like so it is the what I was trying to emphasize was that this archaeoseismology is not only been taken up in Europe, but now slowly we have started uh, uh, having some sort of an left in India also. So Aichatra, if we come, that Aichatra is located in the Indo-Gangetic plain, and as we go ahead in this course, you will learn that how dangerous is and vulnerable is your Indo-Gangetic plain if any earthquake occurs in Himalaya. Okay. So, and there are reasons for that we will discuss. But previous lecture I mentioned one word, that is liquefaction. Liquefaction is a process which is a secondary process, and resulted because of strong ground shaking. Now coming to Aichatra, this is close to Bareilly, this site, and it has its own historical importance. Okay, it is fortified structure excavated in the past by archaeologists, And so what we were looking here was that we wanted to do a GPR, ground penetrating radar, looking for the buried structures. Okay, but we did that. We got very good evidence, but at the same time we also saw the signatures of the past earthquakes which affected the sites also. So that what I would like to show and discuss here. So Aichitra, as I have been emphasizing that it is located in the Indo-Gangetic plain, and Indo-Gangetic plain is vulnerable to that. So what we did when we saw some signature which could be related to the strong ground shaking, and probably uh, as a result of a great earthquake or major earthquake which occurred in Himalaya during that period. Okay, so that's what we wanted to have the correlation. So we also looked at the seismicity. Modern seismicity, of course, will not help, but we looked at that whether there were earthquake in Himalayas during that period when this site was flourishing actually. So we did couple of surveys here, and the background of this, if you see uh, this is a Buddhist site, and which was, like, we can say that it was flourishing during 1300 to 1100 AD or so. Okay, so that is again an important point, because after that, what was the reason for this the site to face the crisis, and it got damaged or ruined actually completely. So as I told that we worked with Archaeological Survey of India in this region, and this area was been scanned using GPR. This part also we will discuss when we are talking about the technique part. Okay, what is the GPR and all that. But this is a wonderful technique, very robust technique, which is available to see such buried structures. So we know we not only use this instruments for buried identifying the buried structures preserved in subsurface stratigraphy, but we also use this to identify the young deformation in the near surface stratigraphy, we can say. So this is 200 megahertz antenna, and we are doing we did the survey way back, like more than 10 years back, in Aichatra region, and what we found, that what was interesting. So we did some surveys outside the main structure, because uh, the understanding of the ASI and mostly the archaeologist is that the fortified structures will have some sort of in small settlements in the surroundings. So that keeping that in mind, we surveyed one mound, and this was the excavation. Of course, we initially we did not understand that what is the reason for this, because this is completely wall structure. If you see, then it is seen, it is sagging here. Okay, so we did not pay much attention initially that what could be the reason for this, but definitely later on, after having more features or the signatures of similar type, we were able to justify it that this is related to some major earthquake, but not related to the flooding events. Because most of the time, what we see that the archaeologists, they say that there was an epidemic because of some reason, the whole area was when affected, people got killed or died, and then probably there was a flood in the nearby stream or the river, and that resulted into the completely ruin the abandonment of the site. Okay, but here what we found was sagging of wall or the wall floor, and then we also see the similar feature in the GPR. Okay, so this was the sort of an advantage we got here to compare our GPR as well as the excavated sites. Okay, then we also visited the site and looked at some excavations which were been done by the ASI. Okay, and what we found was that the fallen wall structures over here, if you see, then we see a sand dike that is which is related to the liquefaction. Just remember this about the sand dike, and we also call sand blows. Okay, so we will talk about that. So this is the process of the liquefaction. Okay, now liquefaction I will mention briefly here. Usually it is related to the, if you are having the loose sediment, water saturated sediment, and during strong ground shaking, what will happen is that the package or the connectivity between the different grains and the pores, because if you have the porous deposits, basically sand, cohesive less material, then you will have pores in that, and that can get water saturated. Okay, but during ground shaking, this all connectivity between the grains will collapse. Actually, it will densify, it will go down, and the pore water pressure increases there. So because of that, you will see that the pressure is been the liquefied material will be poured out on the surface, and that uh, like we can say breaking the different layers, and then it will come out and like in sand blow, or we can say even similar to what we see in the volcanic eruptions. Okay, so that is what is liquefaction, but we will discuss about liquefaction in detail when we are talking about the site effects and the ground effects in this course. Okay, so what we found was the fallen walls one. Okay, so this was one part which very well connected us the with the evidence or the signatures one should look at, uh, which we saw in the beginning. Okay, in that chart. So this is one, and this again the fallen wall in one direction we see, and then waved up or warped brick floors. Okay, and the previous slide which I was showing sort of in sagging was also related with this type of activities. Okay, so the process probably was the strong ground shaking at this around this area, and could have been resulted because of the major earthquake in Himalayas. Okay, then there is the Bhim Gaja, which is a very huge structure in the center of the site. Okay, there also we found that there is a displacement of uh, bricks. Okay, so displaced walls also we were able to see, which you can see here. Okay, so this is very clear cut protruded walls here. So bricks were been displaced back and forth. Okay, because of the ground shaking. Similarly, at the same Bhim Gaja, what we found was that there was again a warping of the waved up walls. We were able to see, which you can see here, is completely waved up. Okay. Now this cannot happen because of the some different process. Okay, this because it is quite heavy structure, and good foundation is there. So this could have been affected because of the strong ground shaking. Then we also looked at the geological evidence, and those were the sand dikes. Okay, in the sediments. So this like gave us a clue that probably this area was affected by strong earthquake rather than your floods. Okay, and even when the dikes liquefaction process was on, it might have ejected a lot of material from down, and that what you see is sort of an brick floors which are here, and then vertically aligned bricks very close to the conduit. This is what you are having, the conduit. Okay, so this portion is in your conduit through which the material has been poured up on the surface. Okay, so this were very clear signature suggesting about that this area got affected. Because now if we try to compare the structures, you can talk about the intensity, and that can help in like reducing the risk in that area in future. So these are these are the all what we are trying to look at in the archaeological sites or the ancient settlements, that helps us in having the future prospective in terms of the safety. So we looked at the seismic events, historical events in this area, and then what we concluded. Of course, it is we were unable to date the sediments and all that from Maichatra. We will try in future, but what we concluded that this site was flourishing between 11 to 13 or 13 to 11 AD, 1100 AD. So earthquake during that period could have resulted into the damage. Okay. So, we looked at whatever the data was available with us based on the paleoseismic studies or based on the historical data. So, there was an event of 1100 AD which was reported from Nepal, and this was a major earthquake in that area. Okay. So, investigations around Ramnagar in the footfall zone, we also found that there is an evidence. Again, we later on we also did study and we were able to fix up this event, and that was around 1200 to 1400 AD. Okay. So, if we compare that, then the Aishatra is from Laldung, that is in the close to the Ramnagar area. The distance is hardly 150 kilometers. Okay. And 120 kilometers from Laldung. So, these two places they were able to identify this 1200 to 1400 event. Okay. Whereas, if you look at the evidence which has been shown or which was unearthed from the Nepal part, that is 1100 AD, was sitting almost 600 kilometers, which is too far for that. Okay. Because the 7.8 magnitude earthquake will definitely affect 300 400 kilometers or so, in terms of it will not crack or rupture that area, but it will the seismic waves will affect the far distant located areas. Okay. So, we suggest that probably this 1100 was not possibly responsible for the destruction, but the demise of the site may be dated around it might have like related to this 1200 to 1400 event. Okay. So, this is a sort of an indirect dating we have done, indirect connect the we can say that it has been correlated with this earthquakes which were been triggered or identified from the paleoseismic investigation. The 1100 AD earthquake from Nepal was also identified from your paleoseismic investigation, that is earthquake geology, and then even the 1200 to 1400 was also through that only. Okay. So, this helped us that okay, if similar earthquake occurs in this region, that is here Kumaon region, that is going to affect the areas which are sitting in the periphery of the radius of 100 to 150 or 200 kilometers from the foothill zones. Okay. Now, as I was mentioning about that the signatures which have been indicated in the chart by the European side, that what will happen to the columns and all that. So, there is another study which we did. This was immediately after 2001 Bhuj earthquake. There is Hiroshima earthquake was there, and magnitude was 6.4. But 6.4 was quite good enough to trigger liquefaction and as well as to rotate or displace the heavy stone columns. Okay. But these columns were not, but these are the all in Hiroshima, this were the graveyards, but they are quite heavy actually. What you see the blocks which have been placed here, others in the on the top of the graves. So, they got rotated actually. Okay. So, even Japanese people have tried to understand that what could have been the ground shaking at that particular point. Okay. So, this block is also like it is if you can see the patch here, then you can identify that it was earlierly aligned like this, and now it has been rotated over along this. Okay. So, this is the rotation direction, and that also helps to some extent to understand that from which side the wave came and which side could have been the epicenter. Okay. So, we did this survey. Of course, this is a very conventional type surveys one can do, but they are important. Okay. So, here also you see there is a huge very heavy column is there, and that also got also displaced. Okay. And you can see the rotation of this blocks over here also. Okay. So, they have been rotated because of the strong ground shaking. Similarly over here, this one is your older alignment. Okay, it goes and it has been rotated like this. Okay, so this type of rotation was observed, and it was similar in most of the graveyard stones which have been kept. Okay, so again you can see over here, this is the earlier one was this one. Okay, so and similar features we try to see in the ancient sites. Okay, so this is an example of the liquefaction which took place and sagging of the area, and that can be visible because of the displacement of the boundary walls here. Okay, and extensional cracks were formed, and definitely this is related to the process of liquefaction. Okay, that what we call lateral spreads. Okay, and this was my home where I stayed, and there also I found like I experienced that ground shaking. It was quite uh, it was difficult to stand. Okay, now coming to the Kutch region. Okay, we identified one old temple, and in that region we thought of let us uh, look at what could be the reason. Okay, now Kutch region is again like one can say we have been talking about the seismic zonation map, and we also discussed about that. Okay, Himalaya is one of the most seismically active zone. Okay, zones in the world, and then we have the Andaman here, and then Kutch because of its own reasons why we had like multiple earthquakes during the historical time, and during 19th century also. Okay, and recent earthquake was 2001 earthquake. Kutch is again like you have the mainland here. This is the mainland, and earlier the story is very interesting in Kutch, but we will discuss later on. So this whole area is like an island. Okay, so this is in how the Kutch name came is in the name is based on what we call the uh, tortoise. Okay, tortoise in Gujarati is been called Kachba, and that how this is what we learned from our uh, seniors and all that this Kutch has been named based on Kachba because it was this island was completely covered or engulfed by ocean when or shallow sea we can say in past. Okay, when this area was flourishing and having the Indus Valley civilization and all that. Okay, now again Kutch has number of fault lines right from you can start from south and go up to your north. You have multiple fault lines which are active, and this part we were talking when I was showing you that how we plotted the earthquakes, from gazetteers we took the data and then we plotted on this. So this is the same structures we are having: the Katrol Hill fault, Kutch Mainland fault, Island Belt fault, Alaband fault, and Nagar Parker fault. Okay. 2001 earthquake was triggered over here in this portion of Kutch, and probably was on the of course the rupture did not come right up to the surface, it remained blind, but some groups they believe that rupture was on the surface, but there is no clear cut signatures of that. Okay, so this was the earthquake, and then we did carried out some survey after the earthquake. Detailed surveys were being carried out, and later on we thought of why not to look at some old temples which are there in Kutch region. Okay, so this is the temple of what we call Manjil in Kutch, and which was affected by 2001 Bhuj earthquake also. Okay, so we'll stop here and continue in the next lecture and discuss more about uh, the, the the effect of earthquake 2001 on this temple, and whether there were signatures of the damage from the past earthquake also or not. Okay. So thank you so much. Namaskar.